Next, we'll see the language accepted by a Turing machine. For that, we need to construct a Turing machine. First of all, to check any language whether it is accepted by a Turing machine or not, we need to construct a Turing machine. And after that, you have to consider any string of the language, and you need to see that that is accepted by a machine or not, machine that you have constructed or not. So how do you start checking whether the string is accepted by the Turing machine or not? You need to start from the start state and followed by the string is your input, okay, and then you need to take so many steps and finally you can get in this format, that is alpha 1 p alpha 2 alpha 1 p alpha 2, in the sense p is a final state. Finally, because after 0 or more steps you need to get this way, that is p is a final state, should belong to a final state, and alpha 1 and alpha 2 need to be a content of a tape symbols, or I can tell which is a string including a tape symbols, okay. Now that's why, to check whether the language is accepted by a Turing machine or not, we are going to construct a machine on the language 0 to the power n, 1 to the power n, such that n greater than equal to 1. For this, I am going to construct a Turing machine. Now, what is the idea to construct a Turing machine? How exactly we are going to construct a Turing machine now? So, for example, I am going to consider the input of this format. So, 0 to the power 3 and 1 to the power 3, that is a string of this language. Strings of this language, considering n as 3, are taken like this. And what is 0 to the power 3? We have to replicate zeros 3 times as well as 1 3 times. So, we can get a string something of this form. Now, for this, how do we construct a Turing machine? Turing machine, when I was explaining the introduction, I told it's a theoretical model of a computer. Here also you need to construct a Turing machine the way you are actually solving the problem. So here, how do I actually check whether it is according to the language or not? For 1 0, there has to be corresponding 1. For this 0, there has to be corresponding 1. For this 0, there has to be corresponding 1. This is how I should go. Okay. Next, for this 0, there has to be 1, and similarly it should go. Now, what I will do here is, for this 0, I will, whenever I get first 0, okay, I will convert it to x. Okay, I will convert it to x. This is my aim to check. Next, what I will do, for this 0, I want to ensure that there is corresponding 1. There is corresponding 1. So that's why I will move to the right until I get 1. So that means I will cross these zeros and I will try to get 1, and then that 1 I will convert it to y. So this is how I do. What I am going to do, I will first, as the 0 whatever I get for the first time, that will be converted or replaced as x, and then I will move the read write head onto the right, on to the right, until I get 1. Moment I get 1, I will replace that by y, and then read right head after replacing this again should come back and try to get the next 0. Try to get the next 0. So here it was 0, y, 1, 1. This is how it's in the tape. Okay, rest all are blank. You know that rest all are blank. This is your exact content. This is what happens in the after matching the 1 with 0. Next what, once I match y, once I replace 1 by y, then I'll go back till where to get the next 0. So that's why I'll keep moving zeros because I do not know where exactly my first 0 lies. So that's why what I will do, I will keep moving to the left here. When I get this 0 also I'll move left. When I this 0 also I'll move left because I have no idea this itself is the leftmost 0. This itself is the leftmost 0. So what I will do after doing 0 0 left, that is after getting this 0 I'll come to the left, after getting this 0 I'll come to the left, and where I will get, when that is I will reach to a position of a last x, okay. And so moment I get this last x, I will just shift one place to the next. I will just shift to the right and get the 0. Just shift right and get the 0. 0 what I will do, and then I should continue with the same procedure. 0 need to be replaced by x. So earlier what I had x. This 0 also will need to be replaced by, and then traverse through the next zeros until I get 1. So this 0 right, 0 0 right, and before that I even get y's. So what I have to do, I have to shift even with the y's many times, and then I reach y. Okay, next what happens, I will get 1. Moment I get 1, I will shift, replace that by y, and then I'll come back to the left. After shifting this, replacing this one by y, then I will come back to the left, y left, 0 0 left. 0 0 left means until I get this rightmost last x, until I get the last x. Okay, so last x in the sense this is normally comes here in this portion. So when I get last x, what I will do, I will just shift one place to the next, and then I will shift, and then I'll replace 0 by x, and then after that I'll move next to get 1. Okay, here I forgot to write get 1. So this also will be changed to 0. This 0 also changed to x now. Then corresponding 1 you should find, move to y, y, r, y. No, don't change with this you keep it as it is. That's why read y and replace it by y and move to the right until you get 1. Moment you get 1, you replace that also by y. Okay, right. Once you get this y, r, then 1 also you have to replace by y, and after that you come back to the left, this y also left. It's for ensuring that there are no zeros. So after getting this y, okay, y, if you get x, then what you're going to do, you can tell that, So you get here x, and then what you can do, so do not place your rewrite in the middle of the string. So after getting here, before y if you get x, okay, instead of getting 0, that means it's almost done with the conversion. It's done with the conversion of zeros and ones, okay. So there are no zeros, and then you just check is there any ones remaining here. So that's why move back, go to the next y, y, y many times, and then you will reach to the blank. If you get a blank, okay, and also you take a right move and stop it there, that means if you have not got zeros and if you have not got ones after this, that means if you have got a blank after y's, that means this particular string is according to the language, okay. So this step we need to ensure in the Turing machine. So that's why I will start from the start state q1. After that I will replace 0 by x. So first time what I will do, I will replace 0 by x and then shift to the right. After replacing 0 by x and then shift to the right. So now 0 need to be changed to x. Okay, you can 0 need to be changed to x and then shift. After that you take a next move. So you take a next move. How do we do that? Because you know that after changing 0 by x, there may be many zeros before you could get 1. That's why in the state q2, you can loop 0, 0, r. And then when you get 1, you change that to y. When you get 1, you change that to y and shift to the left. You change that when you get 1, after getting many zeros, you will get 1 and change that to y, and shift to the left. That means your read write head would be at this place. Okay. Then again your job starts again. You have to find this 0. That is, after the last x there will be 1, 1. So to get last x, you have to keep moving to the left, and that makes you to that particular step will go and reach to this x, the last x, okay, just before the 0. So after that, after getting from here, you have to shift to the 0. So 1 by L, after that you will get many zeros. So you can see here you are in a Q3, you get many zeros, 0, 0, L, okay, 0, 0, L, 0, 0, L. So that is happening in the loop, and where you will reach finally after doing 0, 0, L, you will reach to X. After X, just you should move to one step next. That's why X, X, R. So that means you just read X, replace it by X. Means what? You are not doing anything with this X. Okay, just you want to go to the next place. So that means again you have got 0. Now again your step continues. You have to find 0. For 0 you have to find corresponding one, then again come back. So from here you have started, 0 will be converted to x, 0 will be converted to x, okay. And then when you get zeros, you just shift 0, 0, r. And this time what? Before getting 1, next one, this one, you got y. So this time you have only one y, but next time to change this into y, you might get two y's. That means there may be a possibility of many y's you getting. So that's why at Q2 you have to do even y by r, y by r. So this time I did y by r, that means you come back, go to the next step in the sense where you can reach the first one, corresponding one of 0. So this time you got 1, okay, this time you got 1, and then change it to y, after that move to the left and see here, this time you got y. So if when you reach this position you will get many y's, isn't it? 2 y's. That means you have to do y by l, and then come back to 0 0 l and then go back to x r. Okay, that step repeats. So that means y by l also you need to do at Q3. This is the change you need to adopt from the second step onwards, y by l. Next again, once you do y by l, you can see here, after changing this 1 into y, you do y by l. Y by l will take you to 0, 0, 0 l. You will take this transition and reach to Q4, 0, 0 l. Now you got 0, 0, 0 l. Okay, only one, but this time only 1. And then where do you reach? You will reach to this position x. When you get x, it's the last x. You have to just make one move to the right. So that's why x, xr. So this time what? You got x, you got this x, this 0. Again you need to repeat the steps. For 1, 0, you have to find a corresponding 1. So 0, x, 0 will reach into x, and then you got y, many y's, y by r. So you can see whenever you get y, you replace it by y. That means we don't want to replace anything. So since it is a triplets form, we have to replace by itself, just to make sure that y has to be there in that particular position. Y, then y by r in the sense next you get 1 you will replace by y, then you come back to the left means y by l, and then you got x. This time what? This time you can see that you have not got 0. That means there is no zeros. Next you have to ensure that there are no extra ones. So that's why from here I have to take a move. So instead of going here, because I'm damn sure I got to know that there are no zeros anywhere. Just we have to ensure that there are no ones. That's why from here you just have to do xxr. So just do xxr. You will land in y and do many y by r. So that's why loop at Q5. After doing y by r many times, you will reach to a blank, because you know that in the tape, other than the input, you will have a blanks, all the sides, both the sides. In the sense, there are only two sides in case of this, if there are input. So this side as well as this side, you have blanks other than input. Okay, so when you reach blank, you just do BBR, that is sufficient, and you will land up somewhere here to another blank, and that is nothing but you have reached to a final state. You have reached to a final state. Okay, and this particular program will ensure even n greater than equal to 0. How? When it is n greater than equal to 0, that means language is empty. Language can even be empty. So in that case, you have to reach to from the start state, can reach to a final state without reading any input. So what you can read in the tape, that is just a single blank. If you read a blank, that is sufficient. That's why if there are no input, if a language contains epsilon, in that case you just do BBR and you will reach to a final state. Okay. So this is about the Turing machine construction, and for this we can construct a table, transition table. You can see here this is a table for this particular, that is the same Turing machine, 0 to the power n, 1 to the power n, where n greater than equal to 0, So these are the states and these are the tape symbols. What are the symbols that is going to be present in the tape? Tape is an infinite tape. Okay. So in the tape, if you remember, zeros and ones are present, as well as 0 will be replaced by x and 1 will be replaced by y. That also you are going to write it in the tape. So apart from that, your blank is present. You are going to make a move on blank. So that's why blank is also required for a tape. And blank is otherwise also it is present. 0, 1, x, y, b, because all these symbols you are going to make use of in case of Turing machine. So let's see how exactly we are going to write this. Q1 on 0. Q1 on 0, this is the input symbol, goes to where? Q2. How are we going to write? We are going to take this portion x comma r comma Q2. So XR Q2, that you can write here. It says that on reading input 0, you replace it by x, and after replacing it by x, read write head should take a next position. That means it should move to a right, and in case of a transition it should reach to a Q2. Now let's check this transition. Q2 on Y. I will not show all the fields. I will show some. Q2 on this particular transition, let me check. Q2 on which input? This is the input symbol, Q2 on Y. Q2 on Y. So Q2 on Y goes to YR, and where it goes? To itself, YR Q2. So this is how you need to fill all the fields. So Q1 on B, there is one more transition, Q1 on B. Q1 on B goes to where? BR Q6. You can see here BR Q6. Q2 on 0 goes to where? Q2 on 0 goes to 0R Q2. Q2 on 1 goes to where? YL Q3. So that's what written. Next, Q2 on Y goes to YR Q2. That is written. Q3 on X goes to XR. X goes to XR Q5. Q3 on 0 goes to 0L Q4. 0L Q4. Q3 on Y goes to YL Q3. So itself. So Q4 on 0 goes to 0L to itself, 0L Q4. Q4 goes to anywhere else. Q4 on X goes to XR Q1. XR Q1. Next Q5 on Y and B. Q5 on Y goes to YR Q5, and Q5 on B goes to BR Q6. So this is about the transition table based on this transition diagram. Let us see now the IDs for the strings. That means we are going to see whether these strings are accepted by your Turing machine we just constructed. Okay. So first of all, let me start the computation or IDs from the start state. The start state of this machine is Q1. Start state of the machine is Q1. Q1, then 0, 1, 1. q1 on 0, q1 on 0. So q1 is this always is the first character of these triples are always uh, the input character, okay, or currently reading character. So q1 on 0, we want for q1 on 0, q1 on 0, q1 on 0, isn't it? So it is going to q2 state, it's going to q2 state. Then what will happen with the input? Input will be replaced by x, input will be replaced by x, and then it moves to the right. That is from 0 it moves to the right means what? So for the first time the read write head was set on 0. Now after this character got replaced, it is moving to the right. That means it is at 1. Okay. So before that, so the next character before that, next character is 1, and the following characters you can write. And this will be the next character to be read. So q1 on 0 goes to where? q2. Always remember this state need to be before the current character, before the character you are going to process. Okay. So that's why identify properly which character you are going to process next. So this state, that is in this case q1 goes to q1 on 0 goes to q2. So that has to come before the next character you are going to read. That is based on this, right or left. Okay. Next, q2 on 1. So let's go to the state where q2 on 1, that is taking this transition. q2 on 1 goes to where? It is goes to q3. Remember, it goes to q3. But what happens with the 1? 1 is replaced by y. 1 is replaced by y. So this one, that is the current, will be replaced by y. Okay, that is the current character. So we don't have any issue. Okay. So x1 is replaced by y, and after that where it is taking the move to the left. That means it is going to come here. Read write head from this character again back to x, isn't it? So now q2 on 1 goes to where I said, that is q3. q2 on 1 goes to q3. So here what character we are supposed to write? So this character replaced by x, this got replaced by and then 1, isn't it? So 1 we have to write this character. So next what? q3 on x now. q3 on x goes to q3 is this state. q3 on x goes to q5. You can see here q3 on x goes to q5, isn't it? So q3 and x goes to q5, but what will happen with the x? X is replaced by x itself. That means there is nothing will happen with this character. So you are going to write as it is xxr. Xxr means where we have come to now q5. We have q3 on x goes to x is replaced by x, and then right means where? To this character. Okay. So before that character we are going to write q5 and then y, q5 y, and then 1, and then 1. Okay. So let me repeat. q3 on x goes to where? q5, and x will be replaced by x, and from this character it is taking a right move. That means, so the next time for the next processing, now we have got xxr, means it goes to the y. So q3 on x goes to q5. So q5 should come here, next y, and then 1. So now q5 on y goes to where? q5 on y goes to y, q5 itself. But the move, what's the move? It is supposed to take right. So the next time the read write head should come here. Okay, so x, y, q phi on 1. So now q phi on 1, there is no state to go. So as q phi on 1 is not defined, is undefined, is not defined, we can say that this particular input, so this input is not accepted, not accepted. So that is about this input. Next we'll see for 0 0 1 1, 0 0 1 1. So looking at the string, one thing is clear, this is of the form 0 to the power n and 1 to the power n for n greater than equal to 0. Okay, so let us do the computation. That means let's try to write the ID. Start state is q1 and the input is 0 0 1 1. So q1 non-zero goes to where? It goes to q2 state, and 0 will be replaced by x and it is taking a right move. First of all, let's understand the move. So currently the read write head is here on this input, that is the character that is next to the state. Okay, so after this it should come here. So let me point for the next time, it should come here. So 0 on q1 on 0 says that 0 need to be replaced by x, this 0 for q1, which is the current input, that is this 0 need to be replaced by x, and then it will go to q2, and the rest of the things will be written here. So that's why I have marked this here. Okay, q2 on 0 goes to itself. So 0 will not be changed, 0 will be replaced by 0 itself, that means 0 will not be changed, but it is taking a right move. So next character need to be this. Currently it is here, read write head, so next time it should be here. So that means q2 on 0 goes to q2, so that should come before this. So x 0 q2 1 1. Next q2 on 1, q2 on 1 goes to, where is q2 on 1 goes to q3, change 1 to y and take a left move. So left move in the sense, currently q read write head is on this, so that means it should come to this character. Okay, so x 0 1 need to be replaced by this, need to be replaced by y 1. Okay, which is the current character? This character for the next processing. So that's why q2 on 1 goes where? I said q2 on 1 goes to q3, so it should be here. So next q3 on 0, q3 on 0 goes to q4, but it is taking a left move. So next time for the next processing, this will be the current character. Okay, so q3 on 0 goes to, the 0 will not be replaced, but it goes to q4. So q4 x 0 y 1. So next q4 on x goes to q1, and it is taking a right move. So the next character to be processed is this. Okay, so x 0 y 1. So the next character to be processed is this. That's why q4 on x goes to where state q1. So q1 need to be before the next character to be processed. So q1 on 0 goes to where? It goes to q2. It goes to q2, and 0 will be replaced by x, and then it is taking a right move. So current character is this. So right move in the sense, next character to be processed is this for the next time. So this 0, and let me write whatever the character before the state, you write as it is. Next character is to be processed is this. Okay, sorry, this, that's why I marked here. So that's why leave the place and write that this 0 need to be replaced. Sorry, this 0 need to be replaced by x. That's what we have told here. 0 need to be replaced by x, and q2 y and then 1. q2 y and then 1. Next, q2 on y. q2 on y goes to y by r, no change. So xx y r in the sense next one, isn't it? So this is the next character to be processed. So before that, q2 on y goes to where? I said q2 on y goes to itself. So the next state should come here before the next character to be processed. Now q2 on 1 goes to where? q2 on 1 goes to q3, but it is taking a left move. So next character to be processed is this. So let me write xx. So before writing y, let me leave a space. So q2 on 1 here, q2 on 1 is replaced by y. So this one also becomes y. Okay, q2 on 1 goes to which state? That is q3. You have to write here. Next, q3 on y. q3 on y is taking a left move. Left move in the sense it comes to this state, isn't it? This particular input character. q3 on y goes to y will not be changed. That means y will be retained as it is. Y will be replaced by y in the sense y will be retained as it is, but it is just taking a left move from here. Earlier it was on y, now it will come to x. So with this character. Okay, next let me write. So x I will write, and after this everything I will write x, y, y. So the state, what's the state you're going to write? That will be decided by this previous one. So q3 on y goes to where? q3 on y goes to q3 itself. So next, q3 on x, xxr in the sense, now currently read write head is on this input character. Now in the next time it will be here. So q3 on x, q3 on x goes to q5, xxr q5. So x q5 on y, y. So next, q5 on y, no replacement on the character, just it is taking a right move, so it will come here. So x, but q5 on y goes to where? It's 10. So xx y q5 y, q5 on y goes to where? q5 on y goes to q5 itself. So this also xx y q5. So next, q5 on what character you have after this? So if you remember, when I was explaining about in the introduction video, I've told that is, if this is the input, the remaining character before this, the characters are blank, everything. If this is the input, if this portion is input, here everything you have blank, here also you have blank. So that's why what we can consider q5 on b. So q5 on b is bbr goes to 6 state. 6 is the accepting state. So we can consider this as b. So q5 on b goes to 6 q6 state. q6 is the accepting state. xx yy blank. So blank, see this I will not represent like this, blank, and then I will reach to a q6. Again, as you know that after q6 also there will be blank. So this says what? So this is the input what you have processed, okay, and this is the final state. This is the final state, and your input is now converted to xx yy, means that there is corresponding, and there is no input characters remaining. Input characters remaining, that means 0, 1 are not remaining anywhere. It means that there is this particular input has been accepted. Similarly, the last problem that you can solve it on your own. This is for your reference. You can solve those problems. The last problem. Last problem is 0, 0, 1. So looking at this input, one thing is clear, that it is all not of the form 0 to the power n, 1 to the power n. That means finally you may have to land up either in one among the non-accepting state. So you will never reach to Q6 state. So that's about the Turing machine on 0 to the power n, 1 to the power n, and how any input can be processed using Turing machines, or how we can represent IDs for a Turing machine.